Hello, General Chemistry. Today we're going to talk more about reactions. Specifically, we're going to talk about indications of a chemical reaction. How can we tell if a chemical reaction has occurred? Well, we know that a new substance is being made. So what lets us know a new substance is being made if we're just out here in the real world and we're not looking at a sheet of paper? Well, one piece of evidence that may indicate that a chemical change has occurred is that if gas is produced. But there is a catch to this, because you can also produce gas by boiling a liquid. So if you produce gas by boiling a liquid, that is not a chemical change, because the formula of that substance is still the same, whether it's in liquid form or gaseous form. So you have to have a substance rearrange its particles, its atoms and molecules, in order to make a new thing, which is a gas. That might look something like this right here. If a popular example of this is baking soda and vinegar. If you mix baking soda and vinegar, it will make carbon dioxide, and you can see all of those carbon dioxide bubbles as those chemicals mix. Let's go to number 2. The second piece of evidence that a chemical change has occurred is that a solid is formed, but just like gas, we can form a solid by freezing something. If you freeze something, like you take water and you put it in the freezer and it comes out as ice, that's still H2O. You have not changed the molecular formula of that substance. But if you take a substance, rearrange its atoms and molecules, and you make a new substance that is a solid, then you do have a chemical change. So what does that look like? That we've actually done in our class. When we were mixing some chemicals, we made precipitates. If you take two different substances and you put them together and they make these like cloudy, powdery substances, that's a solid. That powder is a solid. So you can make precipitates from mixing these two substances. So because we weren't freezing, this is an indication of a chemical change. So what else do we have? We have color changing. So sometimes a color change can be an indication of a chemical change. If you make a new substance and the new substance has a new color, well, then you have a chemical change. The complication with color is that sometimes you can get color change by blending, and that is not making a new substance. So it's still tricky. Let's take a look here. Here's an example. Oh, no, not that. We're not there yet. Here's our example. Rust. If we have iron, that iron's got that gray, silver, like dull silverish type of color to it, but when it rusts, it turns into this reddish brown. That's a color change, and that is not because rust is essentially an interaction between iron, water, and oxygen. Oxygen is clear, water is clear, iron is this grayish color, but when they react over time, we start getting the reddish brown. That is not due to blending. That is a new substance being made with a new color. So that's another piece of evidence. We can also have a new odor being produced. Our noses and the noses of other organisms are actually chemical detectors. So if you don't smell something and then the smell changes, that means a new chemical has been made or a new chemical has been introduced to the environment. A classic example that we are now ready for is this business. That milk smells bad because there are chemicals in there that were not in there before. Some bacteria got in there and they started eating up that milk and they started making a byproduct that does not smell good. So we know that we can't drink the chemicals in that milk anymore because there have been chemical reactions that we don't, to make chemicals that we don't want in our body. So thank you, nose, for keeping us aware of the chemical reactions that are bad for us. Finally, a good indicator of a chemical change is that energy is being released or absorbed. And one common example of energy being released is light, and another is heat. So if heat is being released, then we're going to notice a temperature increase. And if heat is being absorbed, we're going to notice a temperature decrease. So some examples of that include burning a match. In this, we can feel the heat from the match, so energy is being released, and we can see the light. That is another type of energy that is being released. And then an example of energy being absorbed are the instant cold packs. You know, the dry kind that are not cold when you get them, but then you break them up and you mix them up, and then they become really cold really fast. Those instant cold packs are an example of a chemical reaction that absorbs heat. So, quick review. Our clues for a chemical reaction are gas is being produced, but not if we're boiling. Solid is being formed, but not if we're freezing. A color change occurs, but not if we're blending. A new odor is produced. And finally, energy is released absorbed, as most commonly light or heat. I hope this helps. Struggle well.